Hello everyone and welcome back to Wednesday and Thursday's lecture. We are going to be talking about lesson 19.2 where we're going to discuss how to minimize our solid waste. So by the end of this section, we should be able to discuss the importance of reducing our waste and describe how composting and recycling can help reduce the amount of waste. And that's what we see here is a bunch of recycling bins, and our guiding question is, what is the best way to manage our solid waste? And in 2007, we have a fact here that Americans recycled or composted nearly a third of municipal solid waste, saving energy equivalent to 10 billion gallons of gas. That's pretty impressive. It'd be nice to see that continue. So go ahead and turn in your workbook to chapter 19.2, and we're going to, of course, start off with our vocab like we normally do, and write in your definitions for source reduction, biodegradable, composting, recycling, and material recovery facility, or MRF. All right, so waste can degrade water quality, soil quality, and air quality. So if it's degrading our soil, water, and air, it's also degrading our human health and the environment. Waste is also a measure of inefficiency. So reducing waste can potentially save industries, municipalities, and consumers both money and resources. And finally, waste is just ugly to look at. For these and other reasons, waste management has become a vital pursuit. There are two main strategies for managing solid waste, and that's going to be reducing the amount of solid waste that we produce, and recovery. Recovery includes both composting and recycling. Recycling is not a concept that humans invented. Recall that all materials are recycled in the ecosystem. Therefore, recycling is a fundamental characteristic of the way natural systems function. And if we look at our screen here, we can see a distribution of air quality, water quality, land quality, and then some extra ones just thrown in there for good measure. But we can see basically the bottom of the scale, red would indicate that's a bad area or the worst area, and that bright blue would indicate the lowest or best area. And we see that we have, if we're looking at the Florida, especially in the Tampa Bay area over here, it shows us having not good air quality at all. You don't start getting some good air quality and up until you get into the Panhandle, and then of course in the Midwest. Water quality though is very good, and we know Florida is known for its springs and rivers, so that's not super surprising to me. That looks good. Not so good in the Midwest as compared to the air quality, right? They have better air quality, but they have worse water quality. And then it says land quality. We're good there too. And same Midwest, not as good, and then out in the West and California area, even worse. And then we have, I like this one. Oh, we have actually not too many bad weather days according to this. That's interesting. All right, so we said our two strategies are waste reduction and recovery. So what is waste reduction? Let's start there. And many industrialized nations must deal with the issues of the ever-increasing waste. More people, more consumption, more waste. Waste managers are now relying on reduction, reuse, recycling, and composting to deal with their waste. As a result, they are greatly reducing the amount of solid waste that gets disposed of in sanitary landfills or incinerators. So when we reduce the amount of waste, we lower the cost of disposal and recycling. We also conserve resources and produce less pollution. Preventing waste generation this way is called source reduction. One way to achieve source reduction is through less consumption, so just buy less things. Other strategies for source reduction include less packaging, banning certain plastics that can be harmful or frequently not disposed of correctly, or designing goods that last longer. So to reduce waste, we can save items and use them again, or substitute disposable goods for more durable ones. Habits as simple as bringing your own coffee cup to a coffee shop or bringing sturdy reusable cloth bags to a grocery store can over time have sustainable effect. You can also donate unwanted items or shop for used items yourself at yard sales or at places like Goodwill or Salvation Army. Over 6,000 reuse centers exist in the United States, including stores run by organizations that resell donated items. Besides being good for the environment, reusing items is also often economically advantageous, which means that the items cost less. Well, as they should because they're used. But it's a benefit to the environment and to your pocketbook. We can also reduce packaging, right? So reducing packaging cuts down on waste as well. But how? When and how much should we reduce? Packaging can serve very worthwhile purposes, such as preserving the freshness of foods, preventing breakage and tampering, or providing information. But too much packaging is extraneous, which means it's over the top or it's not needed. Consumers can help reduce packaging waste by choosing goods with minimum packaging. You can also buy foods in bulk or buy unwrapped fruits and vegetables. Manufacturers can also help by using packaging that's more recyclable. They can also reduce the size or weight of goods and materials. This reduction in size has been successful with aluminum cans, plastic soft drink bottles, and even personal computers. We can also choose to reduce our use of non-biodegradable plastics. So each year, Americans discard 100 billion plastic grocery bags. The lightweight bags, they're our major source of waste and litter. Because most plastics are not biodegradable. It does not decompose or break down naturally, which is what biodegradable means. Plastic bags have been around for only several decades. Therefore, it's not known how long they take to break down, or even if they can break down. In nature, that is. In fact, most plastic material can last for centuries in the environment. Even worse, plastics can choke and entangle wildlife. Several nations have either already taxed or banned the use of plastic bags. When Ireland began taxing plastic bags, most people stopped using them. San Francisco became the first city in the United States to ban non-biodegradable plastic bags. The interesting thing seeing that happen here is just before the coronavirus, we actually saw a ban on plastic bags and people were moving towards charging you or or encouraging you to bring your own bags. And after this pandemic, they actually reversed several of those laws, saying that the use of bags that were reusable were spreading infection. So I just bring that up to remind you that there's always two sides to every coin, and there's pros and cons to every decision that we make. And sometimes there's not always an easy right answer or an easy wrong answer. Sometimes it's a little more complicated than that. Another way we can have waste reduction is designing our products to be more durable or last longer. Think back to the days if you have something, a tool, or some sort of contraption or toy even, from maybe a great-grandparent or a great-great-grandparent. You might notice that it's in really good shape or it still works after all this time, and maybe something that you've bought similar or comparable, much more recent, has already broken or fallen apart or needed to be repaired. So it's that idea of getting back to things the better and more well made it is from the get-go. So like using metal parts instead of plastic parts internally in a tool will make that tool last longer. It can also mean that that tool can be serviced and the parts can be replaced. So instead of just chucking the whole drill because there's an internal piece that's broken, you would have taken that older tool to a shop, and then someone would have taken it apart, replaced the broken piece, and then put it back together, and you wouldn't be wasting or throwing away as much trash, right? Because you would be repairing the drill and throwing away a small broken piece. Or maybe not even throwing away. You might even be able to weld it or fix it in some manner. So it's the idea of getting back to that. So if we increase the lifetime or the durability or life expectancy of the objects that we use all the time, our cell phones, our laptops, our tools, our even in the kitchen, our appliances, if we design them to last longer, then we will reduce waste. The downside, though, is that for people who are selling those items, you won't have as many people buying them if their items aren't breaking, right? So to maximize sales, a lot of companies kind of intentionally design things to wear out quickly, or they'll use a plastic part instead of a metal part because it's cheaper, but that plastic part will wear out and get damaged, and then that item will need to be replaced. So just some examples, like I said, computers, just any kind of toy or gadget, even your tennis shoes, sports gear, just disposable goods like pens and cameras and cell phones. The better they're designed, the longer they'll last, but the less you're buying them. So there's a trade-off there. So let's expand on that, the financial incentives. So some states or municipalities use economic incentives to reduce waste. For example, there's a pay-as-you-throw approach to garbage collection that uses a financial incentive to influence consumer behavior. So in these programs, municipalities charge residents for home trash pickup according to the amount of trash they put out. The less waste the household generates, the less the resident has to pay. More than 7,000 of these programs exist in the United States. There's also a bottle bills, which represents another approach that uses financial incentives. So 11 U.S. states at least use those laws, and they allow consumers to return empty bottles and cans to stores and collect or collection facilities, and then they'll receive a refund. So generally it's 5 cents per bottle or 5 cents per can, and then the first bottle bills were actually passed in 1970s, and it was to cut down on litter. But they also served to decrease the amount of waste and encourage recycling. In states where bottle bills have been enacted, the laws have been both popular and effective. In fact, bottle bills are recognized as among the most successful state legislation in recent decades. States with bottle bills have reported that their beverage container litter has decreased by 69 to 84%, and their total litter has decreased by 30 to 64%. So we can see a chart of the success of the bottle bills here, with several of the states that have enacted those bills, which was Michigan, Oregon, Massachusetts, California, New York, and then you can see the aggregate, the total for the United States. So it says here that data suggests that bottle bills increase recycling rates, and that the higher redemption amounts boost the recycling rates further. So there's some states that give 5 cents for a bottle, but there is some states that give more. So the graph is showing us that the 5 states with bottle bills shown in the graph all have higher recycling rates than the average for the United States as a whole. In Michigan, the only state that has a 10-cent deposit, actually has the highest recycling rate of all, which would make sense because they're receiving the highest return for recycling their bottles. All right, guys, so that's it for Wednesday's lecture. We're going to take a break here for 19.2. Make sure that you've completed your vocabulary and go ahead and answer questions 1 through 5 in your workbook. When you're done, head back over and finish up 19.2. Hello, everyone, and welcome back to Thursday's lecture on 19.2, and we're going to be starting with waste recovery. So we're starting by looking at a chart here that tells us about recycling and composting. Since the 1980s, recycling and composting has increased in the United States, and with that means there's a reduction in how many items are making it to the landfills or the incinerators. So recovering our solid waste is the second strategy for waste reduction. Remember, the first one was just to reduce how much we were consuming, which would mean a reduction in how much waste was being made. But the second method is recovery. So composting and recycling, getting back that waste and then doing something with it before it makes it to the landfill. So when we recover waste, we take material out of that waste stream, like I was saying, so that it doesn't end up in the landfill or in the incinerators. Prime examples of recovery include both what we see on our chart, composting and recycling. Industrial waste is not regulated in the same way as municipal solid waste. As a result, materials that could have been recovered end up incinerated or in a landfill. According to the EPA, in 2007, we recovered almost a third of our municipal solid waste by recycling or composting it. The data for 2005 are shown in the figure on your screen. That amount of recovered waste shows to almost 85 million tons. By recycling and composting this waste, we saved energy equal to or more than 10 billion gallons of gas. We also prevented the release of more than 190 million metric tons of carbon dioxide, or CO2. That's about the same amount of CO2 that 35 million cars release each year. Let's talk a little bit more about composting, the first of two methods for waste recovery. Composting is when we are able to convert organic waste into things like mulch or humus through natural biological processes of decomposition. The compost can then be used to enrich soil. People can place waste in compost piles, underground pits, or specially designed containers. As wastes are added, heat from microbial action builds up in the interior and decomposition starts. Banana peels, coffee grounds, grass clippings, autumn leaves, and countless other organic items can be converted into rich, high-quality compost through the actions of earthworms, bacteria, soil mites, sow bugs, and other detrivores or decomposers. Home composting is a prime example of how we can live more sustainably by mimicking natural cycles and incorporating them into our daily lives. Municipal composting programs, there are actually almost 4,000 across the United States as of 2010. And these composting programs divert food and yard waste to central composting facilities, where the waste decompose into mulch that community residents can use for gardens and landscaping. Nearly half of the U.S. now ban yard waste from the municipal trash collection, which is helping accelerate the drive towards composting. Approximately 1/5 of the U.S. waste is made up of material that can be composted. So composting will reduce landfill's waste, but it also enriches soil and helps it resist erosion. It also encourages soil biodiversity, makes for healthier plants and more pleasing gardens, all while reducing the need for chemical fertilizers. So now we're going to talk about the second way, which is recycling. Recycling, of course, is the collection of materials that can be broken down and reprocessed to make new items. Recycling reduces the amount of waste that ends up in landfills and incinerators. In the figure on your screen, you can see a recycling loop. It contains 3 basic steps: the collection and processing, manufacturing, and purchasing recycled products. All 3 steps are needed for successful recycling programs. So let's talk about each step. Collection and processing is the first step in a successful recycling program. It is going around and collecting any recyclable items. Some communities have locations where residents can drop off their recyclables. Other communities have curbside recycling, in which trucks pick up recyclables in front of your home. Curbside recycling is rapidly growing because its convenience increases recycling rates. About 9,000 curbside recycling programs across all 50 states are now serve nearly half of all American households. But you also need manufacturing. Manufacturing is the second step of the recycling process, and it begins at a material recovery facility. A material recovery facility, or MRF, are places where collected recyclables are sorted and prepared for processing. Workers and machines sort items using automated processes. Magnetic pulleys, optical sensors, and water currents, as well as air classifiers, separate items by weight and size. MRFs clean the materials and shred them so that industries can use the processed materials to manufacture new goods and materials. In the third step of our recycling process is purchasing. We have to have a consumer that is willing to buy the goods that have been recycled. In order for the recycling loop to function, the consumers and businesses must complete that third step. Recycled material is also called post-consumer waste. In step 3, industry uses post-consumer waste to create new goods for consumers to buy. Many textbooks are made from some post-consumer paper. Many glass and metal containers are now made from recycled materials. In some city parks, there are benches and pedestrian bridges made from recycled plastics. Glass is sometimes mixed with asphalt to create a new material called glassphalt for paving roads and making paths. Even clothes can be made from recycled plastic bottles, as we saw and we can see in the figure on the left. So if it's so wonderful, why don't we see more recycled products? Well, there's limits to recycling. Recycling rates vary from one product or material to another. Recycling rates also vary from state to state. Recycling rates among U.S. communities are anywhere from less than 5 to almost 50%. The rapid growth in recycling over the past 2 decades is due to 3 factors: economic forces, the need to reduce waste, and the satisfaction of protecting the environment by doing the right thing. Recycling's growth has been propelled in part by economic forces, as established businesses see opportunities to save money and as entrepreneurs see opportunities to start new businesses. It has also been driven by the desire for municipalities to produce waste and by the satisfaction of people take in recycling. So what we have here is the general rates of recycling in the different states across the U.S. And so we fall in the 20 to 30% recycling rates. You'll notice that red means that very few people recycle, and then orange, yellow, and light green are in the middle, and then that dark green means that over 40% of individual citizens are recycling. So these two forces have driven recycling's rise, even though it has often not been financially profitable. In fact, many of the increasingly popular municipal recycling programs are run at an economic loss, which means it actually costs us money to recycle. The expense required to collect, sort, and process recycled goods is often more than the recyclables are worth on the market once they've been refined. Furthermore, the more people recycle, the more glass, paper, and plastic is available to manufacturers for purchase, driving down prices and profits. So the more we recycle, the more material is available, which means the cheaper it's going to be. So it's a negative feedback loop being created there, which means it's not going to drive the system forward. You're going to be less likely to recycle, or it's going to become less profitable. The more we recycle, the less profitable the recycled goods are for manufacturers to buy. So recycling advocates, however, point out that the market prices do not take into account external costs. In particular, the effects that are not recycling has on human health and the environment, which of course is a valid argument. For instance, it has been estimated that globally, recycling saves enough energy to power 6 million households per year. And recycling aluminum cans saves 95% of the energy required to make the same amount of aluminum from mined virgin bauxite in source material. As more manufacturers use recycled products, and as more technologies and methods are developed to use recycled materials in new ways, markets should continue to expand, and new business opportunities may arise. The steps we have taken in recycling so far are central to the transition, which many analysts view as key to building a sustainable economy. All right, guys, that is it for chapter 19.2 and our last chapter of the year. Go ahead and turn in your workbook for classwork to that section and answer number 6 through 10 for me. Then your last homework, for chapter homework at least, is homework 2. Lesson 2 assessment, just 3 questions again. That is available to you on Pearson, email, or on the video lecture here. All right, guys, have a wonderful weekend, and I will see you guys in our Zoom meetings. Bye.